Let's now look at the swish activation function swish, and it's another variation of the sigmoid function, which in turn is another variation of the exponentials. And as we have seen in these couple of videos, we have an example on the left with x as input values that go from -10 to +10, and these are the inputs to a neuron A, which in this case is using the swish activation function, which is shown up on the top green box. The calculated values are shown in the column A, and the plot on the right hand side shows the blue line, which is the swish activation function that goes from -10 to +10. And the magenta dots are the values that are calculated, that are shown in the column A on the left hand side. And this looks pretty similar to the GELU function that we have seen, where as the values become more negative, the y values start to approach 0, and we will see overlay of this in the code. Let's now go into Colab and look at how we can use this function. The first thing we'll do is, and here is the link for the activations in the docs. The first thing we need to do is create the values of x. So let's do that. X is equal to tf.linspace -10 to +10, and we need a decimal there. So this should be 10 dot, and we need 100 values of these. Let's create 100 values, and y is equal to this is the swish activation function we are using now. Keras dot activations dot swish, and this takes in the input value of x. Now we can plot these values. Plt dot plot x comma y, plt dot grid, and we have plt dot grid, and then we have the plt dot show. So this should show us a nice swish activation curve, which looks like this. We can also calculate the values using the relation that we have up above. So let's calculate the values using y2 is equal to this relation, where we need to use the tf.math.exp, and we'll plot those values here. Plt.plot using x comma y2, and it should be an exact overlay of the blue line, and it is. So it's the same set of values we have. Now let's create an overlay plot of the other functions that look similar to these. And why don't we also put a sigmoid in there? I know that that's going to be it's going to look much different, but it'll be nice to see it on this overlay plot. So we have the ELU, which was the exponential linear unit. Then we have the GELU, which is the uh, let's get the SELU, which is the scaled linear units, and then we have the GELU, that's uh, the scaled exponential linear, and this is the Gaussian error linear units, the GELU. So with all of these, we can. There is also MISH, so why not get the MISH as well? So for that, let's type MISH, and again type MISH here. So a whole bunch of activation functions we have, and this time I'm going to comment out or delete that y2 there, because we have already seen it, and we'll start creating labels for this. So this is the swish activation function, and now I'm going to copy all of this and paste it down here. Oh, missing parenthesis. Let's copy this again and create a bunch of paste it bunch of times, and this let's yeah, it shouldn't matter. So this is going to be sigmoid, so copy that. Not there, the one below, we replace this with the sigmoid. Copy this, replace this with the ELU. This is going to be the SELU, then we have the GELU, and then we have the mesh. And hard sigmoid is there, so we'll skip that for now. And so let's rename this sigmoid. Then we have the ELU. Then we have the SELU. And we have the GELU. And then the mesh. MISH. Now let's get the legends. PLT dot legends and run this. And this would be really interesting plot. There's legend without the S. Let's run this again. This is going to be an interesting plot where we see kind of the variations of each of these. So the sigmoid, we would expect it goes all the way up to just 1, but for the others, here are the differences. The swish that we are looking at looks like it is much closer up there. So that's the blue line. Let's see this again. Why don't we do this? I'm going to plot this in another cell right below this. So we have plt.plot, plt.show, and the swish is let's get the grid, plt.grid, and we should see where it lies. So this crosses, it touches 0. minus 0.5 minus 5.0. I think this is the one that is the swish. Then we have the mesh, which is looks like mesh and GELU are almost on the same, along the same lines. So if we plot the mesh here, this is going to be the mesh, and plt.legend, we should see that they are pretty close. And yes, those both of them are very pretty close, except for this region right here. So this looks like the mesh and swish, and then we have the GELU that approaches 0 the fastest, and then we have the ELU and the scaled ELU that that kind of plateau away from 0 values for the Y. So that's how the swish activation function compares with these values with the other activation functions. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Until then, please like, share, and subscribe. Thank you.